Hello, we're doing checkpoint 5.6 from section 5.1. Here we have a function, f of x is equal to sine x over the interval from 0 to pi over 2, and they want us to find the upper sum. So it would be a good idea to know what this graph looks like, if it's increasing or decreasing, to determine what kind of sum we will be using. Sine of pi is 0, sine of pi over 2 is 1, so this is where we're going to end. And we want to find or estimate this area. So the area looks like it's increasing, and if we want to find the upper sum, we probably want to use the right endpoint. So upper sum is going to be the right endpoint. And we can get started with approximating by first trying to figure out what this thing looks like in a number line. We're going from 0 to pi over 2, and we want to break this up to 6 equal parts. So we essentially, our delta x, if you remember the formula, is b minus a divided by n, so that's pi over 2 minus 0 divided by 6, and that's going to give us pi over 12. So pi over 12 is our delta x, and that means for each of these things we're going to have steps of pi over 12. I think this will cut in half, and then we'll cut each of them into 3 pieces. That will make 6 pieces. And from 0 we add pi over 12. And then we're going to keep going. So pi over 12 plus pi over 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. So that's 1, 2, 3. 4 pi over 12 is pi over 3. And then 5 pi over 12 is just 5 pi over 12. And then 6 pi over 12 is pi over 2, which is at the end. So these are the numbers that we will be using. If we will be using the upper estimate, we established that's going to be the right endpoint. So these are the points that we're going to want to use. So we're going to start with, this is x sub 0, but we're going to start with x sub 1, x sub 1, x sub 2, all the way up to x sub 6. Okay, now if we were to graph it, I don't think they're asking us to graph it, but we'll do it anyways. So this is the first cut in half, that's pi over 4, pi over 3, 5 pi over 12, and then backwards pi over 6 and pi over 12. And for each of them using the right endpoint, we will draw the rectangle, and we can clearly see that these will be overestimates because they are above the area of the graph that we're looking at. Okay, so that's our picture, and let's write out our sum. So this is going to be a right endpoint approximation with n is equal to 6, and this will be the sum as I goes from 1 to 6 of sine x sub I. So we're going to put these values in, and then we're going to multiply this by delta x, which is pi over 12. And we'll remember that this is delta x, and this is your function f of x sub I star, or in this case x sub I, because we're just dealing with the right. Okay, we'll put in those values, so there'll be sine pi over 12, sine pi over 6, sine pi over 4, etc. So instead of just writing it all out, you can actually use a computer. Desmos has a sum function. You type SUM, and then you have the sum, and it'll create the sigma notation with the I is equal to, or N or K or whatever they're using for the subscript. and then you just put in the function and then x sub I star, whatever x sub I star is. There's a formula for this too that we'll eventually see. And then we have the delta x. So when I put this in the calculator, I got 1.125. Okay, that's it. I hope that helps. Good luck.